Hi, Adam is live now. Feel free to start when you are ready.
Okay. Okay, I'm ready. Yeah, I will start. Hello, I'm Aidan. Welcome to Klaymakers 23. I'm one of the tech leader leading implementation of Klaytn Core and Square. Welcome all builders for Klaymakers 23. Because of the successful finish of Klaymakers 22, we are back with Klaymakers 23 and the huge amount of the prizes. So Klaymakers 23 Hackathon have a huge prize pools over $1 million, including the sponsored credits. And the hackathon will start at October 10th, and it will be ended at November 30. So you should know about the duration, and you should build your application in the scope of the following 3 tracks. So one of the main track is DeFi. So I think you already know about the DeFi and how important it is in blockchain ecosystem. And the other 2 things, real world asset and metaverse and gaming tracks, are the area Klaytn Foundation is currently focusing on. So probably you heard about the news. Klaytn will have gold-pegged tokens and will introduce more real-world assets. So like this, we are currently focusing on the real-world asset, and also the metaverse and gamings are very good will be very great area that can be easily implemented on Klaytn, because we already have the metaverse and gaming related SDKs, and also Klaytn has very famous for cheap and fast speed. And in this hackathon, developers will have a lot of bounties, so including the credits. So after winning the hackathon, you can build your implementation or using the credit of Google Cloud, or you can get smart contract audit or using the credit that is rewarded from the hackathon. So, and also we have more credits. So watch the following our sessions that will explain what is the exact amount and the area of the bounties. So keep watching our updates, and also keep watching our online workshops and other sessions introducing Klaytn technology, and also give some education materials. It probably help your implementation. And after the end of the hackathon period, we will choose some finalists, and then they will give the demo day, so everyone can see the demo day, and also they can guess who will be the winner of the Klaymakers 23. So happy hacking and enjoy Klaymakers 23. And if you have more questions, then check the QR code link, and you can get more information in the link. Before starting the current my presentation, I will give some update about Klaytn mainnet, because the Klaytn mainnet hard fork is scheduled to the next week. So this hard fork's name is Shanghai compatible hard fork. So this hard fork will enable the Shanghai EVM that is equivalent to Ethereum's Shanghai EVM. And also we enhanced a little bit of the EVM security. Also, after upgrading this, our mainnet will support the recent Solidity version. Sadly, currently, the recent Solidity version not correctly working on the mainnet. So maybe you feel some trouble when you try to deploy the new source code with the latest version in mainnet. But as you can successfully deploy on about testnet, after the hard fork, you can use all of the recent Solidity versions. And so the exact block number enabling Shanghai EVM hard fork is the number is like that specified on the slide, and the estimated date is October 16th. So it is very soon. And so because of the hard fork, all of the Klaytn mainnet node is required to update their version to 1.11.1. So if you are a Klaytn node operator, please check your version and please update your version if you are not using the recent version. Okay, welcome to Klaytn 23 Hackathon. And I will briefly explain the Klaytn's open source journey. So Klaytn is implemented as an open source project since 2019 June. So it is the exact time of the Klaytn mainnet launching. So before launching, we implemented as a closed source, but with the launch of the Klaytn mainnet, we start to build our Klaytn core protocol as an open source. So already, we had more than 1,500 days, and during that period, we have more than 32 versions and almost 6,000 commits. So it is a little bit long journey in the blockchain scenes, I think. So during the journey, we met a lot of ecosystem projects. So thanks to other ecosystem players, we had huge number of the Klaytn applications or supported protocols. So Klaytn is not for the developer only, for in Klaytn Foundation or specific persons. We are open, so it is for everyone. Anytime you can see the progress of Klaytn core development, and also you can participate in. So let's be open, communicate, and get inspired and each other. Okay, so I will give a little bit information about the Klaytn technology. So this is one of the features in Klaytn version 1.11. That is, the feature is called state-DB live pruning. So I will introduce the little bit detail of this technology, and probably you will know how Klaytn core developer develop new features and how we are thinking to make our new features. So actually, this feature is just one part of the Klaytn 1.11, but I think it is a very powerful feature, reducing blockchain node operation. So this session will be very helpful to understand how to how blockchain storage is stored and maintained, and how important the reducing blockchain storage is important. Okay, so motivation is like that. As you can see on the right side of this slide, the full archive Klaytn node requires a lot of storage size. So it is almost it's more than 16 terabytes currently. So and among the size, the 90% of the storage are related to the state trie. Of course, I think most of the node operator operate their node in the more light mode. So most of the node doesn't require that much of storage, but actually I just implement I just want to explain that storage is a very huge portion of the blockchain storage. So, but even though the state trie occupies a lot of storage, I mean the hugest part of the storage, but all the state trie data is not utilized frequently because when you try to use your application, mostly they request only the recent data and recent balance, and everything is related to the recent. So old data is not that much used. So for some node, the old data is completely non-required because their application doesn't need to access to old data. So, and also in blockchain, the is very one of the important characteristics of blockchain is persistence. So, but even though we remove the state trie data, we can regenerate the data if we have the full data of block itself. So even though we remove the state trie, we can check the integrity of the blockchain node storage whenever we want. So it means that the state trie data is removable. And actually, state-DB live pruning is not the first feature related to that motivation. Almost, I think it's more than 2 years ago, we also implemented a storage-related feature called the state migration. So this feature removed the old state trie and make a new state trie with the current state data. But this feature have little bit downside. As you can see this graph, the storage size of state migration node is grow like this. So sharply increase and then sharply decrease and increase, decrease, increase, decrease, like the shape of so. So even though we can reduce the size of storage using the state migration feature, node operators should execute that feature manually. And then if they don't execute that feature, then storage size grow very sharply. And also the feature requires a lot of memory because the feature have to read all the data of the current state trie. So there are some downside of this feature. So we think, what is the ideal increment line of storage? The line should be looks like this orange graph line. So if we can achieve this kind of the orange line, then our storage size will be maintained stably, and we only require small storage size. So it means that node operation cost will be reduced. Yeah. So as I mentioned about the previous work called the state migration, it has some limitations because it is very heavy features. It requires too many disk I/O. I mean the input-output task, and also requires a huge memory, and it also requires lots of the long execution time. But even though we can execute that feature during the synchronization, so using the node, but it requires lots of time to complete every steps of this feature. And also, node operator should manually execute this feature because it requires too much resource to be enabled as automatic way. So, so many node operators choose another way to reduce their storage rather than using the previous work. That is very easiest way, just downloading the recent chain data snapshot. It is not the kind of the recommended way in Web3 scene, but it is more easy and more comfortable. So we thought we need another feature that can be used by most of the node operators. So we thought, okay, what if a node contained only the last n stage, and then it automatically removed the old block whenever the block number increases 1. So if the recent block number is increased by 1, then the oldest state try should be removed. So like this approach, the Klaytn node only have the fixed range of the state try number, and then if the is synchronized, then it will store the new state try and then remove old one, and store new one and remove old one. Like this way, node can automatically manage their storage, and also the size of the work will be very small, because every time block, the node only have to store only the state of the one block, and only need to reduce the state of the old block. But there is some challenging. Actually, we also thought this kind of approach a few years ago, but we decided to implement state migration at the time because of these challenges. So I will explain about the challenges first, and then I will explain more detail about the solutions. So one of the challenging point is that multiple referencing cases. So this image is simplified state try structure. So under the root hash of the state try, there are some state nodes, and at the end of the state try, there are the child node having the data of each account. But in this state try structure, these two red dot is totally different account. So two dot should be identified as the different one. But when the red dot accounts have the same balance or have the same contract, at that time, the red dot actually stored the same data. Then the data when the count is stored in the database, the red dot is stored as a single item. So in that way, the database can store two accounts as a single item. So people think it is very efficient because we only need the space for one account, but actually we can represent two different accounts. But it is kind of the challenging point when we try to remove the data, because let's think about that. The first red dot, this red dot is changed to another data. So we can suppose the scenario like this account send Clay to another account. So the balance is changed and also is changed. Then the data of this red dot should be changed to another one. At that time, we should decide, okay, do we have to remove the data of this red dot, or we should maintain this right side of the red dot? Okay, it is very hard. Actually, you probably think, obviously, we should state the red dot because the right side of the try are still using the data of this red dot. But in the database side, we don't know how many numbers of this red dot is used. So it means that when we store the data in database, we should know how many times this data is referenced by another node. So like 1 and 2. At that time, and also when this reference is removed, like through these changes, then we can know that, okay, the reference is changed to 1, and if this reference is changed to 0, then at that time we can remove the data. But this kind of the counting reference requires lots of the disk I/O as well. So current design of the state trie and the level DB structure, it is hard to implement reference and count. So this is one of the hardest thing. Without the reference and count, we don't know whether we should remove the data of the red dot when this data is changed to another one, because perhaps it should be used by another try. But yeah, so this is one of the challenges. And the other challenge is re-referencing cases. So let's think about this scenario of this image. So because of some reason, the red dot data is changed to another one, and because of the another transaction, this change is reverted back. So we can think like that. There is a smart contract account, and the contract account stores the data 1, and then the data is changed to 2 because of user update this data, and then later this data is updated to 1 again. Then the data is moved back to the old one. Okay. So, I'm sorry. But let's think about that. We are trying to store the state trie within the period n. So we try to store the data of the last 100 block number tries. So when firstly the red dot is updated to another data, at that time the window should not contain the red dot data. But one block after, if the red dot is recovered, at that time we should contain the red dot. But because we are having the full view of this long-term period, even though the red dot is removed during that time, this window still contains the state of the old state. It means that the state of the before changing. So during the period of n, we cannot remove some data. So because of this kind of re-referencing cases, it is very hard to determine which trie node is really obsolete during some specific period. Okay. So we try to achieve this goal, but before we implement a new feature, we analyze this feature would be really efficient or not, because if the duplicated key value data is very popular in our Klaytn mainnet storage, then the deduplication will make a lot of the overload in storage. So we analyzed the trie data, and we found that a lot of only of 1% of the data is duplicated. It means that we don't have to we can just distinguish every data representing each part of the state trie node. And also we analyze the pruning of latent state trie nodes on every block processing is heavy or not. So we analyze the disk IO, expected number of disk IO, and we calculated the overload of the memory and computation. And we also checked the required hardware spec, because we should suppose our node operator's environment. So after checking all the things, we thought, okay, if we have if we make some kind of deduplication of the storage data, then probably the state trie live pruning will be possible. So, okay, I will explain the each steps of state live pruning. So at the first time, we try to introduce extended hash to make a unique database key for each trie node. So let's think about this. In this picture, the left red dot and right red dot are totally different node of state trie, but those data is stored as a single item in the database layer. But we try to make those two data different. So it means that the red dot will be stored separately in database. So by introducing the extended hash, all of the state trie node data should be unique. So it means that each node of state trie is mapped to level DB data 1 to 1. So to implement this kind of extended hash, we introduced extended hash nonce. So on top of the normal hash. So this extended hash nonce is about 7 bytes. So, and this hash nonce is monotonically increasing global counter. So state trie make another node of the state trie. At that time, the state trie, the key of the state trie node will be updated like this extended hashes. And so like this kind of the concept, so each state trie node will have the unique data and unique key in database layer. And also we remove and also we introduced the kind of the marking system, because when this red dot is changed to another data, and let's suppose this the block number of this change is 101. Oh, I'm sorry, but we cannot directly remove this red dot data at the block number of 1.101 or 102, because we want to maintain the red dot data during the specific window n. So the red dot data should be maintained for a specific time, and then the data should be removed after the expiration time. So when the red dot data is distinguished, is not the recent data, then we should mark, okay, this data will be removed someday later. So, and specify the block number of these changes. So if the red dot data is change it to another data at the block number of 101, then probably this data should be removed and at the block number of 101 plus n. So, and these are two main steps. So, okay, I'm sorry. I will also explain more about how to remove. So, after n blocks, we checked what kind of the data is expired. So, after n block, we checked all the marked data, and then if we found some the expired marked data, then we removed that data. So at every block, we checked all the marked data and then removed all the expired marked data. So with this feature, we checked how this feature is efficient. So when we try to after we trying this implementation and we check the reduction of the state trie size. So it turns out that after adopting this feature, the state trie size will be maintained about 200 gigabytes in Cypress network. So it means that the state trie data in the archive nodes was 14 terabytes, but for the node using this feature, 14 terabytes doesn't need it. They only need 200 gigabytes and little bit of the extra data for just in case this. So this feature can reduce the average size of the block, average size of the node storage. And also, on every block, this feature stores some data and removes some data, but the number of the remove and store is not that many. So the computation and the memory usage is not that much. So, and also we implement this kind of the storage and the reduction task as asynchronously. So the IO task or the other memory behaviors is not that much requires resource. So if you are node operator of Klaytn, then probably you can try to enable this feature, and then you can see your storage space is not that much required, like current requirements. So please see the result and then reduce your node operation cost. So what is the next? What is the development item Klaytn is currently implementing is permissionless network. Yeah, we already announced that we are trying to implement permissionless network. Currently, our network is kind of the hybrid network. Anyone can participate in Klaytn network as an endpoint node, but cannot participate in a consensus network without a permission. So, after the implementing of this feature, anyone can participate in consensus network. It means that anyone can participate in any roles in Klaytn network. So when we design these features, we set 3 principles. One is the openness. It's obviously we need to be open because main core is making open network for validators. So without centralized authority requiring consensus participation, all of the participants in Klaytn ecosystem can operate Klaytn validator node. And also the validator network should be accessible to everyone. So anyone can see the information of the validator network and its behaviors. And the second principle is autonomous. So its validator evaluate the status of network from the protocol policy. So after checking the status of the other node, each node will estimate the current status of the entire network. Usually in the P2P network, it is hard to see the overall view of the network, but each validator node will try to collect the data they can, and then they try to estimate the current situation of the Klaytn network. And then they try to request some changes and also try to share their view to others. Then if most of the validator nodes agree on the specific view, at that time, some kind of specific action will be executed. So for example, let's think about that. There is one irresponsible node in our validator network. So the node doesn't produce block sincerely. So block generation is getting delayed. At that time, other validator node automatically distinguish, oh, this node is very irresponsible. So they automatically, the validator will vote to kick out this kind of the irresponsible node. So if most of the validator node agree on that kind of kick-off request, then the irresponsible node will be kicked out. But maybe another situation can happen, even though our node is very responsible, but some other node think this node is irresponsible because of some kind of network issues, or if one of them is malicious. But even though this kind of situation happens, the action, the network change require the agreement of the master validator. So only some malicious node or the network issue cannot make the change of the network. So it will be very safe. And also the third thing is performance preserving. Yeah, of course, Klaytn is very famous for the fast block time and finality, and also high performance TPS. So we should preserve this performance. So we try to keep the finalizing time, and also we try to keep our TPS. So we can reduce the block time more, or we can increase TPS more, but we decide to preserving the current spec of performance. And rather than increasing the performance, we try to put the resource to make an open validator network. But even though this the open validator network is introduced, our performance will not decrease. So this kind of our principles is converted to the three key features. So openness will be a self-validator onboarding process, and the main feature of the autonomous is validator evaluation framework, and performance preserving way it is mapped to automated penalty system. So the the bottom three key features will represent three principles, and these three features will be the main feature of permissionless validator network. And of course, we have more small milestones to complete permissionless Klaytn. So this is some of them. So some of them are already implemented on Klaytn network, and some of them is only introduced by KIP spec. But so like this, we are keep building a milestone step by step, and after we complete all the things, then Klaytn will be the permissionless validator network. So yeah, so I will explain a little bit of these five tracks of the Klaytn roadmap. So the first thing is about the random. So this random is used to implement unpredictable proposal election. So currently, Klaytn's proposal election is a kind of random, but it is very easy to estimate. And also, we select a random proposal sequence bulkily, so it is very easy to calculate who will be the next proposer. But when we introduce this random feature at that time, our protocol will be very unpredictable. So only the block is generated at that time. After producing the block, at that time, the node can calculate the next proposal. And also they cannot calculate the next proposal. So only the next proposal can be calculated. But because Klaytn block time is very short, only 1 second. So at the time, some kind of those attack is only allowed for very short period of time. It's a microsecond digit. So this feature will be very helpful to protect Klaytn network from kind of targeted DOS attack. And also, we are going to introduce BRS signature schemes, and this scheme is used for Landau, and also it will be used for block commit compression. When you see the whole scheme of the Klaytn block header, you probably can see the list of the committees. So block header contains a list of committees and a list of the commits that is generated by the committees. But this data is very huge compared to other data. So we try to compress this data as a single length of the data. So if our validator node introduces BRS signature schemes, then all of the validators commits will be compressed as a single signature. So it will be very helpful to reduce the storage size of the future Klaytn node. And the third track is about the smart contract, and we will introduce this new concept called the system contract. So system contract is something like the very important contract in the Klaytn network, and the contract is unique. And this contract can influence to all of the ecosystem. So one of the example of the system contract is address book that containing the validator, all information of the current validator node. So this kind of the contract will be more introduced in Klaytn network later with the adoption of permissionless Klaytn. So we explicitly define the definition of the system contract, and also we will establish the management process of system contract. So we try to introduce the system contract registry. It is also implemented as a smart contract. And on top of this registry, all the system contract data will be stored. Specifically, the address of the other system contracts will be stored in this registry. So everyone can see all of the system contract list only seeing this registry contract. And so one of the system contract that will be introduced with the adoption of permissionless Klaytn is candidate registration contract. So candidate means that the candidate or validator. So before a node is being a validator, the validator should register as a candidate first using the smart contract. So it means that all the validator and the candidates of the validator will be registered and managed by a smart contract called one of the type of system contract. And also we will establish this kind of the management process of the smart contract. And the next track of the roadmap is validator evaluation. Currently, we already implement metrics of the validator evaluation. So each node will evaluate the other node using that performance metrics. So they will validate other candidates or validators, and also they will score for the to evaluate them and get a consensus with other validators. So if all of the validator think some specific validator have a very low score at that time, the validator will be sent to a penalty system, or if a candidate have the high score, then the candidate will promote to a validator. So this kind of the validator evaluation system will be used to promote validator or demote validator. And the last thing is about the penalty system. So this system also requires the specific feature code system transaction that is automatically generated by the validator. So if a specific situation happens, then node can notice the situation happens, and then they will generate a specific system transaction. So for example, if a node found a specific validator has very low score, then okay, then the node will think automatically a node will generate a system transaction that requesting a penalty of the irresponsible validator. And this kind of the system contract requesting penalty will be used for the validator demotion process. So, and also this kind of the system transaction is used to manage the system contract and all the other concepts later. Okay, so that is about the Klaytn technology recently built and also will be built later. And happy hacking with Klaytn 23. And I will give a little bit update for the Klaytn 23 as well. So like this session, we have more sessions to give the more information related to Klaytn, and also we will have the demo sessions and also ceremony time. So keep tuned and stay tuned and keep watching our videos, and that will be very helpful for your hackathon participants. if you have more questions, and don't forget to check this QR link. And also there is another invitation for you guys. So okay, check this link, then you can see the more information related to Klaytn building. So this also have the more some information related to how to implement Klaytn applications or tools you can use, or SDKs and libraries and everything. So check this link first before you try to make an application in Klaytn network. Okay, thank you very much. Okay, I got a question from the channel viewers. So one of the question from YouTube is, what is the main things that Klaytn solves? Okay. Actually, Klaytn has launched almost 4.5 days ago. So at that time, there is no blockchain that can be used in enterprise level. It means that very high performance blockchain. So we designed the high performance blockchain first. And because of the trilemma, you guys probably know, it is hard to satisfy all of the security and decentralization and also scalability. So we should sacrifice one of them. So we more focus on the scalability and security. So that is the Klaytn mainnet is the result of that thinking. So actually, what the originally Klaytn mainnet it is supposed to be infrastructure of the enterprise blockchain services, and because and also the one of the main characteristic of Klaytn that is called fee delegation is also implemented in that kind of the thinking. So when enterprise try to introduce blockchain node, the key management of the retail user are very hard thing. So we try to give some kind of the key delegation features, or some kind of the custodial wallets or something like that. So providing that kind of the little bit less decentralized but very helpful tools that can be leveraged by enterprise. We try to we try to achieve the adoption of blockchain in the world. Yeah, but I think that nowadays there are many high performance blockchains, and also Ethereum also try to solve their scale of the issues using L2 and other things. But of course, there are some trade-off for all of the technology. But I think that currently the TPS or the performance is not that much important in blockchain scene. So now Klaytn is more focusing on the specific business area. So recently, the most focusing area is RWA. So Klaytn tried to adopt the real world assets because actually DeFi or the token economy is a very important part of the blockchain ecosystem, but like this kind of the bear market, all the value of the assets decreased very sharply. So we thought we need some kind of special asset that can guarantee the minimum value of the network or the value of the token. So the answer of this question is the real world asset. Real world asset has value in real world as well. So adopting the real world asset, that means that Klaytn assets will have the minimum value of will achieve the minimum value in the network. So we think the adoption of the real world asset will be a kind of the explanation of kind of the logical explained why blockchain network can have the values. Okay. I don't know, this would be this can be an answer for for you guys. Okay, if you have more questions, or if you want to have more discussion with Klaytn developers, and then please come to our Discord channel, and then please give more questions or give your ideas. Then let's discuss, and let's implement Klaytn ecosystem together. Okay. Okay, thank you. And okay, that's it for today. Thank you, and please listen other sessions and give more of your opinion in Klaytn Discord channel. Thank you very much.